So these two tables are showing you the difference between linear functions and exponential functions. You're supposed to look at the y values of each of those functions to compare them to find out if they're adding or if you're adding or subtracting each time by the same number, or if you're multiplying or dividing each time by the same number. So linear functions and exponential functions are the same, are similar, because you have equal differences or equal factors. With quadratics, you don't have that. So this is what you do. When you look at these, it says linear functions grow by equal differences over equal intervals. So the equal intervals mean that you're going up consecutively the same amount each time for x. Do you guys remember that? What consecutively means? One after the other?
No.
So if you're at 0, what's the next one? 1, then 2, then 3, then 4. So are there equal intervals? Yeah. So look at the second table. So we're just making sure that they have equal intervals. Does that make sense? So you're making sure that it's going up by 1 each time. Intervals, it's like the range of numbers. So instead of counting by 2s, we're counting by what? 1. So this is how they're the same. If we look at, so this is what we're focused on, right? Because of the equal intervals, we're focused on the y table. So if we are at 30, how do you get to 26? Minus 4. Does that work? 26 minus 4, does that give you 22? 22 minus 4, does that give you 18? So does this work all the way down? So does it have equal differences?
No.
Yes, because it's constant. So write this down, constant difference of 4. So each time it's being what? Subtracted by 4. So if it's added or subtracted, what kind of function is it?
Linear.
Yes, linear is, and you're going to write this down again. Linear is adding or subtracting by a constant difference. If these numbers were to change up, would that be a constant difference?
No.
No. Good. All right, let's look at exponential functions grow by equal factors over equal intervals. So first of all, is there equal intervals? Look at the x. 0, 1, 2, 3, right? It's going by what equal interval? 1. All right, let's look at these numbers right here. All right, if you knew that they were exponential, the first thing you would look at is what you multiply by. But if you didn't know, the first thing I always do is I always look at these tables and say, okay, I'm at 1, how do I get to 3? And you could say plus 2, but then you could come down here and say, okay, well, then I would have to do plus 2, and does that work for the whole table? Yes or no? It doesn't work for the whole table. So it's not going to be plus 2 because 3 plus 2 is 5, not 9. So times 3 times 3. Okay, so each time to get from 1 to 3 is what? 3. To get from 3 to 9 is 3 times 3. Does this work each time? Okay, so what do I have? Equal factors of what? I have equal, so I have equal or constant, put this down, constant ratio or factor of 3. That means that if I'm multiplying each time or dividing each time, what kind of function is that? Exponential. So put exponential, and that's either multiplying or dividing by a constant factor. That makes sense? So linear, you are adding or subtracting. Exponential, you are multiplying or dividing. Awesome. Okay, so I want you to flip over the sheet, but that's the right side. Yeah, I want you to look at the sheet. Yeah, but I'm not looking at that side, so I'm going to show you what I want you to look at. Okay, it does say partner A, but it's okay because we're going to do this together. So a table of values is shown for f of x and g of x. Which function represents a linear function? Explain how you know. First of all, what's the difference between, why does one say f of x and the other one say g of x? One is the y. They're both the y, but they're two different functions.
That one is exponential, the fx is linear, and then dividing by 5 is.
Awesome. And you just moved here. Awesome. Okay. So you're going to put +2 on your paper. So this one would be what? Linear. And this one is exponential. And I know this is exponential because I know you're not subtracting by 200 each time. So, and if you don't know the rate, remember what I showed you, the shortcut, you can always divide the second by the first. And what's the rate or common factor? That was 0.5, right? So each time you're multiplying by 0.5. If you're multiplying, it's exponential, right? Multiplying by a decimal is the same thing as, multiplying by a decimal is the same thing as dividing by that same number. Okay, this part, so if you're looking at this part is important. These little possible sentence stems. So instead of just saying linear and exponential, you have to say, I know the function is blank because of blank. I know the common difference for this function is blank. So you have to like come up with different ways to say these things. So like, you have to come up with reasoning. So you know that this is linear because why? So put f of x is linear because why? Good job. Because your common difference increases by what? 2 each time. So you got that? What's something intelligent I can come up with for this, for exponential? that's good. What you said was good. So g of x is exponential because do we call it a common difference? What did I call it before? Ratio or a factor, because your common ratio or factor, because that means you're multiplying. Because your common ratio or factor is decreasing by what? By 0.5 or half. Yeah. But people look at it differently. So it's like 10% of people look at it as a fraction, and like the rest, like 90% of people look at it like it's a decimal. So I try to do both. All right, look at number 2. Consider the graph below. Which type of model would be a better fit, linear or exponential? Explain your answer. So look at that graph. Imagine connecting the dots. Yeah. What do you guys think? Connect the dots. You don't need that, because watch. Connect the dots. Does this look like a straight line? So is it linear? It's exponential. Why? Exponential because the graph is curved. Not a straight line, right? Based on the model, what is f of 0? What does that mean? So write this down. What is the y value when x equals what? 0. Good. Write this down so you remember what that means. What is f of 0? And how would I even know? Look at this. Like I'm looking at when x is 0, right? But if I continue the graph, it's going to go up, 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 up. But guess where it would cross? What do you think? If you had to guess. F of 0. Where would it, if you continue this graph going all the way up, up, where do you think it would cross the y-axis? So it gets closer and closer, but like, think about it. Like, would it be touching at 18? Would it be touching here? No. What about 20? 22, 24, 26? What would be a good estimate? These are going up by what, 2s, right? So a good estimate would be maybe 30, 32. So I'm just approximating it. You see how this is just reviewing everything we already know? Yeah. Okay, so the next one, 2 functions are shown in the table. So you have x, and then you have h of x and k of x. What does that mean? Yeah, they're 2 different functions. That's right. Okay, so one is h of x and the other is k of x. So do you know anything about h of x yet, or k of x? No, so we need to look at what values. The f of x and h of x and all of that, but those are the y values, right? So you have 2 y values. So which function represents an exponential function? So let's look at this. What's the difference? +3, +3, +3, +3. So what kind of function is that? So right, linear. What about k of x? So this is plus 2. Is this going to be plus 2?
No.
No. So if it's going to be exponential and I don't know what it is, then I'm going to take the second term and divide by the first. So divide this. Somebody do this real quick. Tell me what it is. 1 point what? Okay, so each time I'm multiplying by 1.8, does it work for everything? So somebody multiply 19 times 1.8. Well, I'm not 1.8, I'm sorry, 1.18. What is it? What is it? What'd you get? So does this work? Is this going to be exponential?
Yes.
It doesn't work. Because if I multiply, try 37. 37 times 1.18. Try that. 43. Do I get to 43? No. So if it's not linear, and I'm looking and it doesn't have a second common difference, and there's no pattern when you multiply, then it's neither. So this means that it's neither.
I was right.
So there's none of them, right? So you can't multiply and you can't add or subtract. So you would put neither, yeah. And then the last one says, what is the average rate of change? Anytime you hear average rate of change, what should you immediately write on your paper? Y2 minus Y1 over X2 minus X1. And write that down and put, this is the rate or the slope. That's how you find average rate of change. And remember that if there's brackets and it says interval, interval's talking about what, X or Y?
Okay.
X, good. So you have two X's. This is X1 and this is X2 because they're in brackets and you're talking about interval. So I take the table, right? And I go up here, where does it say X? It says 1 and 3, right? Circle 1 and circle 3. So it wants to know the Y values for which one? What? Good job, 1 and 3. So the Y value, so when the X value is 1, what's the Y value? 13, so write that down. When the X value is 3, see the X value? What is the Y value? 19, so write that down, 319. So now you have your X1, Y1, and your X2, Y2, and you can put it into the rate formula to figure out the average rate of change. So I would do Y2 minus Y1. So I'm just taking these numbers, right? And subtracting, get 6. And then X2 is 3 minus 1. So 3 minus 1 is 2. So my average rate of change is, yeah, so my average rate of change is what? 3. 3. And because it's linear, that means that's also your slope. Got that? So that's your average rate of change. So with if it says average rate of change, you're writing down what? So you're writing down Y2 minus Y1 over X2 minus X1.